Good morning, everybody. Yes, I hope it's clear, it's visible. So, hello, I'm Dinesh Kumar R, and today let us try to understand a very interesting topic here, and that is sea floor spreading theory. I hope you guys are following me here, and in the previous two classes I have been dealing with some of the important concepts of geomorphology as a part of endogenic forces, and it is a continuation of that particular class. And let us try to discuss what are we discussing. We'll just discuss what we have already discussed and how we are going to link the sea floor spreading theory with that. So let us begin with the class here. So those who are first timers with me, I am Dinesh Kumar R, and if you like my classes, you can follow me on my Unacademy profile for the various numbers of classes. I am teaching both on the Plus platform as well as on free platform on Unacademy also. So you can follow me on this particular link if you like the classes. So yes, there is a very important announcement for you guys. It is Unacademy Summit 2.0 coming recently, that is 2 days program on January 30 and 31st. It is a summit where you will get chance to interact and listen to these important scholars. There are IAS officers, there are politicians, there are various other scholars who are there. You can see, I hope you all know about Durga Shakti Nagpal ma'am, you all know about Ashok Khemka sir. So you are going to get some interactions with them, and it will be going to benefit you for your upcoming preparations. It will inspire you definitely. It will give you idea of how to prepare with the recent bureaucrats, and it will also help you to understand how this bureaucracy works. You will be directly getting the first hand information from these officers. So all of them who are preparing for the UPSC examination, may be freshers or maybe who has already started your preparation, you all can visit this to get more knowledge about your preparation or to get more clarity about your preparations. Okay, so this is the highlight of the program. It's 2 days program, that is, I hope you have checked the date. The dates are, you can see here, 30 and 31st January. So it's a 2-day program on Unacademy platform, and it is entirely live. You don't need to travel anywhere. At the place of your comfort, you can attend it. There will be 70 iconic speakers, 20 plus talks and discussions are there, and there are various workshops also going on. So don't miss it on 30 and 31st. Now there is another announcement that there is some new batches about to start on the Unacademy platform for CSC 2021, 22 and 23 aspirants, and it is starting from 1st of February. So you can follow these batches. Now all these 1-year batches which is starting from 1st of February, they are in 2 languages. You can see bilingual, that is Hindi plus English, and the English batches are also there. And for 2 years back, that is who are writing in 2023, the new aspirants or those who are still in college and will be writing in 2023, there is an extensive batch. You can prepare for 2 years now, and you can take an advantage of early beginner. So you can do that. And yes, there is another expert batch for 2021 prelims especially, and it is starting again on February 1st. And you can see it is also in 2 languages, that is bilingual and the English languages. Apart from that, to strengthen your basics, Unacademy has come with NCERT batches, and you can see I am also part of these NCERT batches in the English classes. I will be taking geography. I will be giving you idea of how to study this geography through NCERTs and all these particular things. It is also starting from 1st of February. So you can subscribe and get enrolled to these courses. Now it's a new initiative. Unacademy has come with a weekend batch, right? Those who are working in the weekdays, so you can join these batches for various exams. That's for 2021, 22 and 23. You can start your preparation from this weekend batches. And yes, there is a slight increase, or I can say there is the date has been extended for this iconic subscription. Previously it was 25th, but now it has been extended to 31st. So yes, those who are interested to subscribe for the Unacademy Iconic Plus subscription, so I will advise you guys to take the benefit and subscribe it soon before the price rise. And you all know, I hope, that there is various different fees for Plus, Iconic and optional courses, but this is combo offers. If you are subscribing them together, you will get additional discounts. For all the subscription related details, whenever you subscribe, in the referral column you can use my referral code DineshRT10 to avail 10% discount on your subscription. Okay, so let us start with the class here. So today's topic, yes, as I'm reminding you, Unacademy 2.0, 30th and 31st. So don't forget to join. So you can register them on the Unacademy platform now for free. Alright, so let us move into the class. So we were dealing with some of the portions of geomorphology. As I already have explained, geomorphology has two parts. One is the internal force known as the endogenic force. Second is the external force known as the exogenic forces. Now we are dealing with some of the very important concepts which are part of endogenic forces. And which are the topics we have covered? We have already covered something known as continental drift theory. Right, we have discussed the theory of Wegener. We have covered number of aspects. What is this theory? We have discussed what are the assumptions considered by Wegener for this theory. We have discussed the weaknesses of this theory. All these particular things we have covered in the previous YouTube classes. After this, I have taken this particular section which is referred as post-drift theories. What is post-drift theories? I hope those who are first timers, you may not be knowing it. See, we have started with the theory from here. That is this continental drift theory. It started somewhere in 1912, right? And the most important theory which comes after this, I can say it will be plate tectonic theory or plate tectonics. It will be coming in the 1960s. So what happened in this period of roughly 50 years? What happened in this period of 50 years? So this 50 years was, I can say, was the evolution of plate tectonics. That is, during this 50 years, there were various theories which were individually coming up, and these theories will gradually help us in understanding the plate tectonics. So we will be moving into this topic plate tectonic afterwards, but please remember, plate tectonics cannot be understood well without understanding these post-drift theories and the continental drift theory. That is why we have already completed in the previous classes what is convectional current theory. I hope you guys remember. We mentioned about Arthur Holmes, who explained about the convectional cells present in the asthenosphere, and he very clearly mentioned that this is the force responsible for breaking and the drifting apart of the continents. We have discussed that, and in the last class we have also discussed something known as geomagnetism and its application called paleomagnetism. I hope you guys remember, those who have attended the class. Those who have not attended can visit back to my profile here and you can check these classes here itself. So what is geomagnetism? It's Earth's magnetism. What was its application? We have discussed about paleomagnetism, that is the stored magnetism in the rocks that we find inside the sea. So we have discussed all these things, and when we discussed paleomagnetism, we understood very well that inside the ocean that we are getting, there are rocks of different polarity, and that helped us in understanding the Earth's magnetic behavior properly, that how it keeps on shifting its magnetism and polarity. So we have discussed all these things. So as a part of our post-drift theory, today we are going to deal with the third part, that is seafloor mapping and the seafloor spreading theory. So let us try to understand what are the topics we are going to cover within this. So there is a theory known as seafloor spreading theory. Okay, this theory explains that the seafloor is continuously spreading. How? Can you see here? This was a small sea in between. Can you see this was a very small sea? Now this sea, can you see it is enlarging in size? Or if I want to show you something, can you see, when we discussed about continental drift theory, we have studied that South America was attached to Africa. That means there was no water body. Gradually the continent broke away, and that resulted into a birth of a new sea here. And now presently you can see this is a full-fledged Atlantic Ocean. So how did we arrive at these formations? So this is explained by the seafloor spreading theory. So let us try to understand seafloor spreading theory. Now please understand, when I am talking about something known as seafloor spreading theory, before that we have to understand about seafloor. Before I say that seafloor is spreading, it is definitely sure that I must understand how seafloor looks like. For that I am beginning with the topic, that is ocean floor mapping. What do you mean by mapping? I will be physically try to map or study the ocean floor, which is also referred as, you can take this word also, this ocean floor mapping is also referred as bathymetry. It is referred as bathymetry. So what is it? It is the graphical representation of the various relief features that is present inside the sea floor. Good morning Ram Kumar, very good morning. Okay, chalo. So what is seafloor mapping? It is bathymetry. What is bathymetry? It is the graphical representation of the variations within the seafloor. right? So now seafloor mapping. Now whenever I talk about this word seafloor mapping, that means I am going to physically study the ocean floor, right? Now can I say the physical study of ocean floor is going to be very difficult, because if you know about the average depth of the ocean floor, it is roughly around 4,000 meters from the sea level, main sea level, from the surface. 4,000 meters. Some areas it will be 3,000, some areas it may be 6,000 also. It varies, but the average I can say roughly around 4,000 meters. So that means, can you imagine, from the surface you have to go 4 kilometers deeper and you have to study the ocean floor. So definitely pressure increases, you require sophisticated technologies, otherwise you cannot directly reach there. So if I want to talk about this technological advancement, all these technological advancement were happening after the World War II. You might know that during the World War II we have the development of submarines. Now how will the submarine navigate? I hope you guys know they have acoustics, sound waves, they radiate something, it hits with something and comes back, and that's how we measure the distance. Right, so definitely through that, after the World War II we have the development of the acoustic or sonar waves. So as a result of that, we are now capable of doing the ocean floor mapping. So we are going to map the ocean floor. So I am talking about post World War, that is maybe somewhere around in 1940s. Now can I say before 1940s we did not had any idea how the ocean floor looks like, right? So till now the geomorphologist or oceanographer, whoever present, they just thought that ocean floor might be just a flat land. But first time in 1940s, when we actually mapped it with the help of sonar or acoustic radiations, we understood, or the first observation was that the ocean floor is found to be even more diverse than the land. See, what are the diversities on the land? You have mountains, plateaus, islands, plains. These are the major irregularities, or I can say relief features present on the land. But when I tried to map my ocean floor, I found that the ocean floor is even more diverse than the land. See, you are getting, for example, this area where the ocean floor is very shallow, the slope is very less. That area came to be known as continental shelf. Then can you see there is another area where the slope tremendously increases very suddenly. That is the area, that area came to be known as continental slope. There is another area where a deep flat bottom is seen, that is referred as abyssal plain. That is not done. Within that you can see number of minor features, like can you see some crack here? These cracks came to be known as mid-oceanic ridges. There are depressions inside the oceans. These depressions came to be known as trenches. There are parallel chain of mountains along the ridges, on both sides of the ridges. There are volcanic cones found inside the ocean. There are islands visible inside the oceans. There are canyons formed inside the oceans. So when we tried to map the ocean floor for the first time, the observation itself was surprising, and the observation was my ocean floor is found to be even more diverse than the continent. So what are we going to do? We are going to study the observations that we got as a result of sea floor mapping, as a result of bathymetry, or I can say plotting of the ocean bottom relief through the technologies of acoustic or sound waves. This is what we are going to do. So first let me take you through the observations, then I will explain them one by one. So let me directly take you. These are the observations of our seafloor mapping. What was the observation? The first observation, can you see, ocean floor was even more diverse than the land. We have already mentioned that. See the ocean floor, this is even more diverse than the land. My land has limited irregularities, but the ocean floor has tremendous number of irregularities herein. So that is first observation. Second observation, let us see. Linear cracks are present inside the ocean floor, known as oceanic ridges. Can you see here? These are the linear cracks. See, the cracks are linear. So these are linear cracks which are found inside the ocean floor, and these linear cracks are referred as oceanic ridges. So this is my second observation. I got linear cracks inside the ocean. So yes, let us continue from there. Volcanism is active along these ridges. That means this linear crack, which is referred as oceanic ridges, I am experiencing continuous volcanic activities in this area. Continuous volcanic activities in this area. That means this crack is not just a crack. Through this crack, the lava is coming out. Lava is coming out. So I am experiencing volcanic eruption here. That was my next observation. Next, Parallel chains of mountains are seen along both the side of oceanic ridges. Can you see here? On both the sides of this oceanic ridge, you can see these parallel chains of mountains. So these parallel chains of mountains, they are visible on both the sides of the oceanic ridges. So this was my next observation here. So let's move forward. We have already covered 3 observations. Which are they? First one, do you remember? The sea floor is found to be even more diverse than the land. Second observation, I found cracks inside the ocean floor, linear cracks inside the ocean floor, which is referred as mid-oceanic ridge. Along the linear cracks, I got volcanic activity. So I get active volcanoes along the linear crack. Then on both sides of this linear crack known as ridge, I am getting parallel chains of mountains like this. So this is my next observation. Let's move with the next observation now. This is the, please remember, the most important interaction or observation which will help us in understanding number of things. So what does it say? Moving away from the ridges, the age of ocean floor goes on increasing on either side. I repeat, moving away from the ridges, the age of ocean floor goes on increasing on either side. Now check this figure. Do you remember we have clearly drawn the parallel ridge? This is my ridge, this crack. Now what does the observation say? The observation says that as I move away from the ridge, maybe on this side or it can be on this side. As I move away from the oceanic ridge, what I am finding is I get that the ocean floor goes on increasing with respect to their age. How? For example, I am studying a rock of this area, I am studying a rock of this area, and I am studying a rock of this area. What I found is this rock is relatively much younger. This is even more older and this is the oldest one. If I am moving towards this direction, what I got is the rock that I find here is very young. The rock I am getting here is relatively much older and the rock which I am getting here is the oldest one. That means the observation says that this is my linear crack known as ridge. As I move away from the ridge, the age of ocean floor goes on increasing. That is, the material present near the ridge or crack are very young and the material present away from the ridge are the oldest one. So this is my next observation. Let's move further with the next observation. So we have covered these 5 observations. Next, nowhere ocean floor is found older than 200 million years. Now this is a very important observation. Please remember, whenever we talk about land, okay, in geomorphology you will talk about land and you will hear something about shield, this shield or craton. These are very common words in geomorphology. Whenever you hear about these words, shield or craton, please understand this represents the oldest land and the stablest land that is present on the map of the world. We sometimes say the Deccan Plateau of India is part of Indian shield. Shield means very old and stable landmass, which is formed, I can say, with the origin of the earth. It's very old. I can say maybe 1000, 2000 million years old. That old and stable landform which is formed 2000, 3000 million years ago is referred as shield. They are the ancient or the oldest landform present. But when I studied my ocean floor, what I am getting is nowhere I am getting an ocean floor which is older than 200 million years. You forget 1000. See, we are talking about land which is 1000 years old, 2000 years old. But inside ocean, I am not getting any of the ocean floor which is older than 2000 million years old. That means, can I conclude that my ocean floor is much younger? Ocean floor is much younger than my land. Right? My continents, I am finding it more than 2000 million years old, but the ocean floor, I am not getting any of the ocean floor area which is more than 200 million years old. So this is my next observation. So let's move forward with the next one. Trenches are found almost parallel to the coastline and islands. That means whenever I am getting trenches, can you see this one is a trench in the figure. Whenever I am getting trenches in my ocean floor, I find that either they are parallel to the continental margin. Can you see? This is my land. So can you see this trench is very much parallel to this continent? Or otherwise, I can say sometimes you get trenches parallel to islands. Maybe if this is not a continent, this will be islands. This will be islands. So how am I getting trenches? Trenches are getting near the margin of the land most of the time, and they are finding parallel to the continents. If not parallel to the continents, they will be found parallel to the islands. So this is my next observation. And the next observation, let us see the last observation. Sea mounts are found in deformed state near the trenches. What is sea mount? Can you see these conical hills inside the sea? These conical hills inside the sea, they are referred as sea mounts. Whenever I found this sea mount near these trenches, they are found in deformed shape. Deformed means they are not a regular shape. They have been, I can say, destructed or destroyed. They are not in their original shape. They have been deformed. So these are my observations. Now be with me. I am repeating all the observations. Okay, I am removing all these things that I have written here, and I am going to repeat all the things that I have mentioned till now in a short form. So be with me. So what did I say? In 1940, post 1940s, when the development of World War II occurred, we experienced advancement of technology. So as a result of that advancement in technology, we developed various things like sonar rays, acoustics, sound waves and all. Now these sonar waves and acoustic, they are used for understanding the ocean floor. With the help of this technology, we are going to map the ocean floor. Now when we map the ocean floor, what are the observations we got? First observation was, my sea floor is even more diverse than the land. That is, you have huge amount of irregularities inside the sea, even more present than the land. First observation. Second observation, we found that there were cracks inside the ocean. I can say linear cracks inside the oceans. Third observation, along this linear cracks, volcanic activity was present. That is, these linear cracks were experiencing active volcanic eruption. That is my third observation. What is my next observation? On the either side of these cracks, I got parallel chains of mountains. Can you see? These are parallel chains of mountains. This was my fourth observation. Fifth observation, as I tried to understand the age of ocean floor, I understood that the ocean floor present nearer to the ridge will be much younger, and as I move away, their age goes on increasing on either side. That means as I move away from the oceanic ridge, the age of sea floor goes on increasing. This was my next observation, fifth one. That is, the ocean floor is youngest near the ridge, it is oldest away from the ridge. So age goes on increasing on either side of the ridge. Fifth observation. What was my sixth observation? I said I got when I tried to understand the age of ocean floor, nowhere I have got an ocean floor which is older than 200 million years. While when I talk about land, I am even getting land which is older than 2000 million years. So definitely I can say ocean floor is much younger than the continents. Ocean floor is much younger than the continents. So this is my next observation. Next observation, I found trenches inside the ocean floor, and wherever I got trenches, these trenches are either parallel to the continents or otherwise these trenches will be parallel to the islands. So this is my next observation. Last observation, if I get these small sea mounts near the trenches, they won't be found in their regular shape. They will be destroyed or they will be found in a deformed shapes. So these are the observations that we have seen. So are you guys clear with the observations? Those who are watching it live, can you please respond that is the observation part clear? I have not yet answered why you are getting these observations. I have just explained that as a result of ocean floor mapping, these are the observations I am getting. Now please let me know, are all these observations that we have mentioned, is it clear? If the observations are clear, I can directly take you to the theory, that is what is sea floor spreading theory. So I'll just wait for a second for your replies and we'll move forward together. Okay, so I hope things are comfortable here, no doubts. So let's move further. So I am concluding things now. What are the things we have covered till now? We have understood continental drift theory. After continental drift theory, we have studied convectional current theory, where we understood that inside my crust, what is there? Asthenosphere, where the lava keeps on moving like this, creating convectional cells. This was the second thing I have understood. Third thing I have seen, there is geomagnetism and its application paleomagnetism. Then I have taken you to the ocean floor mapping. We have seen the observations of seafloor mapping. So now I'm asking you guys, can you guys feel that ocean floor is in a way spreading by understanding all these concepts? Just do one thing. Do you remember this concept that we have studied about convectional current cell by Arthur Holmes? That means this explains that there is a crust above and beneath that there is a semi-molten material asthenosphere which keeps on moving. The molten magma keeps on moving in this circular way. Now in this figure, can I place this, if I place this circular cell in the asthenosphere here, if I place the molten material which is moving here, so this is my convectional cells, I am placing it here. So my convectional cell is moving. Okay, it is molten material where it is moving. Now can I say when the convectional cell is moving like this, the flat land which is present above it, it will be stretched apart, it will result into its cracks. The best example, I can show you another figure here. Can you see here, this is the cell moving into this particular direction. Here I have cell moving into this particular direction. When the cell is moving in two different opposite directions, can I say this will result into crack of this land? And whenever the land cracks, you get volcanic eruptions. So why I was getting linear crack inside the oceans? Because convectional cells were present beneath that. That is why the landmass inside the ocean was cracking. That is why I got a linear crack. Why volcanic eruptions in this area? Because as I said in the previous class also, my earth is just like an egg. If it cracks, the plasma inside will come out. Similarly, when the ocean floor or simply the earth's floor cracks, the magma which is under huge pressure inside will just come out. So that is why all along this linear cracks, I am getting or experiencing volcanic eruptions. Now, why as I move away from the ridge, why is the age of ocean floor increasing? So can I say it's very simply can be explained from here? Can you see this is the cell, this is another cell. So because of this active cell, the plate is cracking here, the landmass is cracking here. When the land cracks here, you get lava output and lava will spread over this area. Now after some time, as it is on the surface, can I say the lava will cool down and it will get solidified? Now after getting solidified, can you see the cell is continuously moving? So as this cell is continuously moving, can you see the material which was formed here, after some time because of the movement of cell, it has reached here. Can you see this white patch? It has reached here. And the material of lava which has erupted here and solidified, it has reached here. It will take millions of years for this movement. It's very slow, right? So this material which was formed here, it has reached here and here. By the time the gap is again opening up, so you are experiencing new volcanic eruption here. So again lava comes out, the lava will cool down, get solidified, it will form a new ocean crust here. As this cell is continuously moving, this will again further move out. Can you see? This has reached here now, this has reached here now. By the time all of them are moving apart, and on the time I can say as they are moving, there is a new opening and again lava will outpour, they will come and get solidified. That is a new ocean floor. So can I say this ocean floor which I am getting here, it was once upon a time formed here millions of years ago. This ocean floor which I am getting here, it was once upon a time formed here millions of years ago. But what about this area that is just near the crack? Can I say it is just forming now because of the present volcanic activities? So that is why I said that as we move away from the ridge, the age of ocean floor goes on increasing. So is it very clear with this figure why I said this is my crack, that is oceanic ridge, and as I move away from the ridge, the age of ocean floor goes on increasing. Why? Because whatever lava comes in, it comes on the surface and gets solidified. After some time with the continuously moving cell, it will reach here, it will reach here. By the time new magma will again come and erupt, that will solidify, creating new structure. And after some time this will reach here, this will reach here. And by the time you will have another gap, this will again erupt again lead to a new eruption, and that will cool down to form a new ocean floor. So this clearly explains how the sea floor is continuously spreading. So by linking all our observations that we have studied, so what happened here? Can you read this statement now? These observations of seafloor mapping that we have already discussed, coupled with convectional current theory, that is we have placed those cells under this seafloor, coupled with convectional current theory and the concept of paleomagnetism. Why? We have understood that on equivalent distances we are getting same polarity. We have discussed that in the last class. And by comparing paleomagnetism, studies led Harry Hess. He was a very famous geomorphologist of that time. Harry Hess concluded that seafloor is spreading. This is referred as seafloor spreading theory of 1960s. So what do you mean by seafloor spreading theory? Seafloor spreading theory means that gradually, because of the convectional cells present inside the seafloor cracks initially, it creates ridge, and from the ridge the seafloor keeps on spreading. So can I say, you can see this example now. We all remember about Pangaea. I hope everybody knows about Pangaea, right? What is Pangaea? It was a supercontinent in the story of our Wegener, continental drift theory. So Pangaea broke into two. Why? Can you see very clearly? They were attached, but beneath that there was a cell active. Beneath that there was a cell active which was moving in two opposite directions. As the cell was moving in two opposite directions, this led to tension. See, this is the force. So this led to tension. As a result of tension, what happened? This landmass initially got a depression. I can say it might have got a Rift Valley and Block Mountains here. When it further pulled apart, can I say this depression will be filled up by water? That is my nascent sea. That is, I can say it's a beginning of a sea, nascent sea. If it pulls further, can I say the land cannot tolerate and it will crack. And this crack came to be known as my oceanic ridges. Now all along oceanic ridges I will get volcanic eruptions, and from there my sea floor will start spreading outwards. This is referred as sea floor spreading. You can now just link this example here. Okay, I hope you guys all know that this Africa and South America was attached. So there was no gap initially. So what might have happened? Initially tension might have started. As a result of that, crack might have originated here. Now as the crack enlarged, you can see water has entered this area. So I can say that was in this stage, nascent sea. After that again I kept on pulling. So what happened? The ocean floor cracked, and that resulted into continuous volcanic activities, and the sea floor started to spread into two different directions. As a result of this spread, now you can see Atlantic Ocean is a huge ocean. And can I say the ocean is still expanding? Atlantic Ocean is still expanding. Can you see this figure? It's a very interesting figure of Atlantic Ocean. If you pump out the entire water under the Atlantic Ocean, from the Atlantic Ocean, the floor will look like this. Can you see here? This area is my crack that we were talking about, ridge. This area is the crack we are talking about, ridge. All along ridge, what happens? Volcanic eruption takes place. Lava outpouring is taking place. And lava will come and get solidified here. After some time, it will move with the cell and it will reach here. And this material will reach here. So that is how continuously the sea floor is spreading. So this is how our Atlantic Ocean has been formed. And this theory is referred as sea floor spreading theory. So to understand sea floor spreading theory, what are the things you must understand? First thing, you must understand all the observations of sea floor mapping. Then you have to understand sea floor, then you have to understand convectional current theory. Then you have to understand paleomagnetism. Those who don't have better ideas of convectional current theory and paleomagnetism, I will suggest you that you can visit the same Unacademy, this Articulate, and check my previous lectures on these topics. I have already taken continental drift theory, I have taken sea floor mapping, and I have already taken convectional current theory. Then I have also already taken paleomagnetism, and today I have taken the topic sea floor spreading, which is a proper linkages. Now, if these linkages are better, if you are strong with these linkages, now you are ready to study the plate tectonics. So from the next class, what we are going to study is, we will be entering into the next topic that is referred as plate tectonics. So make sure before the next class you cover all these three topics, because plate tectonics is a linkage of all these topics that we have studied. I hope all these topics are crystal clear. So yes, that is all from my part now. Let us stop it here. In the next class, we will see you with the new topic, that is paleomagnetism. So before winding up, please remember there is various batches coming up on Unacademy platform starting from February. right? Then Iconic, the price rise is from 31st Jan. Those who are interested to subscribe, I will suggest you guys to kindly subscribe it before the price rise so that you can get the advantage. For all the subscription related referrals, you can use my referral code DineshRT10. While subscribing, you will get this column here. So here, when you apply this code DineshRT10, all the fee will be reduced to 10%. Your 10% discount will be applied over everything. So this is my referral code. One more announcement. This code, that is DineshRT10, DineshRT10. This code can also be used as an unlock code. What is unlock code? Those who have not used Unacademy platform yet, when you download and use this platform, you are able to access free live classes, which are 1 hour free classes taken by top educators of Unacademy. I'm also live there. I've also taken more than 100 classes there. To get access to these classes, what you can do is, when you enter the app, when you enter these free classes, they will ask for an unlock code. On this unlock code area, if you put this one DineshRT10, that code, that free classes will be unlocked for you guys, and you will get access to unlimited access to those free classes. Right? So that is all from my part today. I hope you guys enjoyed with me and you understood all the class of today. And please don't forget this particular thing, Unacademy 2.0 on 2 days, 30 and 31st. You can register it and attend it free. So thank you. I hope everybody is comfortable with the classes. So thank you. Take care. Stay safe. Bye-bye.